Hello everyone, my name is Neha Kardum and this is the 11th lecture on Introduction to Microcontrollers. In this lecture, we are going to continue the topic instruction sets and we will learn about different new instruction sets in the microcontrollers. So let's get started. So the first instruction set we have here is BTFSC, which stands for bit test F, skip if clear. And the syntax for this particular instruction set is this, BTFSC F, comma B, where F is the file register, B is the bit. So this particular instruction set, it tests for the bit, and if the bit is 1, then the next instruction is executed, or if the bit is and if the bit is 0, then it will skip the next step and will go to the will proceed the 2-cycle instruction. So let's read the description here. If bit B in the register F is 1, the next instruction is executed. If bit B in register F is 0, the next instruction is discarded and a NOP is executed instead, making this a 2-cycle instruction. So this is the same thing which I said before, and in this there is no status is affected. So let's see an example. BTFSC REG1, 4. So this is the instruction set we have used, and this is our file register. RG1 is our file register, and this 4 is the bit. So it's going to test the bit 4 in the file register 1. And then next step is to go to repeat this process. Okay, so this is the 2-line code, and if you execute this code, then let's see what will happen. So before the instruction, PC is your program counter, and here RG1 has this value AF. This is the AF hexadecimal number in binary, and as it says that we are going to test the 4th bit, so the 4th bit is this one, starting from here 0, 1, 2, 3 and 4. So this is the 4th bit. So this is going to check whether the 4th bit is clear or not. So the 4th bit is clear for this particular case 1. So what's going to happen? So if 4th bit is clear, as it says, the next instruction is discarded and a NOP is executed instead. So after instruction, what will happen? Because we have RG1, 4th bit is equals to 0, then we are going to have 2-cycle instruction, means go to will be skipped. So this second code which you see here, go to repeat, is going to be skipped, and whatever is the 3rd step in the program is there, it's going to go onto that instruction, program code. Now let's see the case 2, in which we have different hexadecimal number in the RG1 file register. We have this number, and but all these 2 instructions are going to be executed the same, only there is new hexadecimal number in this file register. So it's going to check the 4th bit. 4th bit is this one, and right now 4th bit is set, which is 1. So after instruction, what's going to happen? RG1 4th bit is equals to 1. So if it is 1, if you read here, it says if it is 1, then next instruction is executed. Means program counter $+1, 1 cycle is executed, means go to instruction is executed. So after this, if you have this hexadecimal number, then immediately after this this line will be executed, and if it was 0, then this line will be skipped, and then whatever is you have the code on the next line after this will be executed. So this was your bit test F, skip F0. And we have used this particular instruction set in one of our programs, so you'll get to know like how we are implementing this instruction set. Now next we have BTFSS, and this instruction set is similar to the instruction set which we saw in the last slide, and it says bit test F, skip F set. So instead of clear, we have here set. So if this bit, So this is the syntax BTFSS F comma B. So this is for B and this is for file register. So if your B bit is a set, then what is going to happen? It is going to skip the next instruction, and if the bit is 0, then the next instruction will be executed. And that's what it says here. If bit B in register F is 0, the next instruction is executed. If bit B is 1, then the next instruction is discarded and an op is executed instead, making this a 2-cycle instruction. Now here we have an example, BTFSS register 1, 4, go to repeat. So before instruction, we have register has this value AF. So this is your AF hexadecimal number, and it is going to check at this 4th position whether the bit is 0 or 1. So we see here the bit is 0, and if the bit is 0, then the next instruction is executed according to this description. So this is 0, which means the next instruction is executed. So right now we have to make a little bit correction to this slide. So this is going to be 1, and this is going to be 2. So you saw that the next instruction is executed and the instruction cycle is just 1. And in the second case, we have this instruction. We have a file register with this hexadecimal number BF, and in this one we are going to test at the 4th bit. You see the 4th bit is 1. And if the 4th bit is 1, then what is going to happen? The next instruction is skipped. So that's why you see here go to is skipped. And this is the 2-cycle instruction. So this is pretty similar to the previous one. The only difference is it is looking for set value, whether it is set or not. And if it is set, then it is going to skip the next instruction. Now next we have clear F. Clear F we have used in the example program, and it's pretty straightforward. It will clear whatever is there in the file register, and in this case a Z status flag is affected, the content of the register F are cleared, and the Z bit is set. Okay, so we have an example here. Clear F flag underscore reg is my file register. This is the new name I've given to my file register. And then if I execute this command, if I execute this instruction set, then what's going to happen? Let's see, in the flag underscore register we have this 0 cross 5A. This is my hexadecimal number, and if I execute this instruction set, then after the instruction what's going to happen? This register will have a 0 cross 0 hexadecimal number. So whenever you use this instruction, your whatever the file register you have used, it is going to clear that file register and will put 00 hexadecimal value. Next we have increment F, skip F0. So this is the syntax for this instruction set. Increment F, SZ, F comma D, and in this case no status is affected. And in this instruction set, what's going to happen? It's going to increment the file register by 1, and it's going to skip if it is 0. So let's read the description over here. The content of the register F are incremented. If the D is 0, then the result will be placed in register. If the D, this is D, which tells you where the data is going to be stored, and if it is 1, then the data will be stored in the file register. If the result is 1, the next instruction is executed. If the result is 0, then it is going to skip the next instruction and will go to whatever the instruction is there after the next instruction. So we have this example code, increment FSC count comma 1. So count is my register. I have named this, this is my file register, comma 1. 1 indicates that I want to store the value into the file register. Go to here is my next instruction. So case 1, before instruction we have 10 hexadecimal value in the count resistance register. So this is my hexadecimal number into this count register. After the instruction, after I execute this instruction, then what will going to happen? So this is going to increment by 1. So this count register, whatever you have in the file register, is going to increment by 1. So you see, this was all zeros, and if you add +1, then this is going to make this value. So now I have 0 cross 1 1 hexadecimal number, and this is a one cycle instruction. Now case 2. So before instruction, my count was FF. So this is the binary number, and if I add 1, so if I use this, like if this instruction set is executed, then what's going to happen? This is going to add +1. So I'll just quickly maybe use a pen here. So what's going to happen? So I'm going to add 1 here, and if you add 1, then you are going to get this result. So if you get this result, okay. So if you get this result, then what's going to happen? This is a 0, all 0. So you see, you have 0 0 hexadecimal has been executed here. I'll have to change this to a pen. Okay, so now we have this 0 0 hexadecimal is executed here. So now the count will have 0 0 hexadecimal. So what's going to happen? 2 cycle instruction, this is going to proceed. It is going to skip the go to instruction here, and then it will go to the next instruction which is there in the program. So you see here how we have incremented the count in the file register, and the same thing we can do it in case of a decrement. So we have this another instruction, decrement F, skip F0. So this is similar to the previous instruction set. The only difference is that instead of incrementing, this is going to decrement. So I have not taken an example for this particular instruction set, and I believe you can create your own example, because you have covered this instruction set already. So you can maybe use this same example, and instead of incrementing, decrement the digit and see like what's going to be your result. So rest of the things are same in the decrement F skip F0, similar to this one. And I'm going to go to the next slide. So this is explain the result of each register of the sample program. So you see on the screen is the sample program which I've created, and I want you to go through this sample program. Now since you already know all of these instruction set, so I believe if you just follow all these instruction set line by line, you will get to know what you're going to get at the end of the result. Okay, so I'll just explain maybe just the start code. So in the start code, we have selected our bank cell port A, and then we have clear F trace A. Trace A, if you clear F, then it is going to set the port A as your output, and then clear F port A. So everything in the port A is cleared. And then you have all these instructions. So I want you to take a moment and just read this program and see what is going to be the result. And now here is the same code which has been put on the MPLAB IDE. So you can also do the same and run the code and see what results you get. So this is the end of the lecture. Thank you so much for watching.